All right, Calcularians, we've got some data from Mars on a Pathfinder mission in July 1997. So in this table, and all we have is a table, we don't have a graph, we don't have an equation, we are given information about certain times and what the temperature of Mars was at those given times. So in these two examples that we're going to do today, we're going to look at how to calculate the average rate of change of the temperature over time from 640 to 905. And then we're going to take a moment and estimate the instantaneous rate of change at the time 905. So we have the table, take a snapshot of that. And to find the average rate of change from 640 to 905, to find average rate of change, I'm going to find the change in temperature over the change in time. So putting that down for a moment. The change in temperature from 640, to 905. The change in temperature was going from negative 67.2 to negative 44.3. So to calculate average rate of change, I'm going to find change in temp over change in time. So my change in temperature was about 22.9 degrees. So I definitely increased those temperatures from 640 to 905. I went from a negative, what was that? I can't read it backwards. Negative 67.2 to negative 44.3. So I went up 22.9 degrees. And from that time frame, that was about 145 minutes. So doing a little math in the calculator, I get 0.158 degrees per minute. So that average rate of change of temperature over time from 640 to 905 is approximately 0.158 degrees per minute. Now in the second question, I want to find the instantaneous rate of change at this moment at 905. But all I have to work with is a table. So I don't have an equation. I can't find the derivative at this specific point. I don't have a graph. I can't find the slope of the tangent line. So what I'm going to do is approximate. I'm going to compare the average change at 836 to 905. And I'm going to find the average rate of change from 905 to 934. So my change in temp over my change in time in these two intervals is approximately, I got about 3.1 degrees over 29 minutes. So this is degrees per minute for that top one. And from 905 to 934, my change in temperature over change in time was about 2.3 degrees over 30 minutes. So I've got these two intervals, one right before the 905 and one right after the 905. I took these two numbers and averaged them. So to find that instantaneous rate of change at 905, I'm going to borrow the average rate before, the average rate after, average them. So I added them up, divided by 2. And I'm going to say the instantaneous rate of change at 905 is approximately 0.0918 degrees per minute. So at that moment, we're getting warmer, not by much, but there is a change. Using a table, using data from Mars to make approximations about instantaneous rate of change.